Today's topic is understanding cycle time, which improves efficiency in operations. Optimizing efficiency by mastering cycle time calculation for streamlined processes. Introduction to cycle time. Cycle time refers to the total time required to complete a single unit of work or to process a single product from start to finish within a specific system or process. It is a fundamental concept in process management and operations. Next is importance in manufacturing processes. Cycle time is a critical metric for various industries, including manufacturing, service, and healthcare. It serves as a key performance indicator, KPI, that directly impacts productivity, efficiency, and customer satisfaction. In manufacturing, a shorter cycle time often translates to higher production rates, reduced costs, and faster response to customer demand. A shorter cycle time indicates a faster, more efficient process. In service industries, cycle time affects customer wait times, service quality, and overall operational efficiency. Understanding cycle time is essential for identifying bottlenecks, process inefficiencies, and areas for improvement. Cycle time measures the speed at which a process operates. By optimizing cycle time, organizations can enhance their competitiveness, meet customer expectations, and reduce waste in their operations. Next is component of cycle time. Processing cycle time. It refers to the time it takes for a single unit to go through the actual work or processing steps within a system or process. This component is usually the most critical when optimizing cycle time because it directly impacts the speed and efficiency of production. Wait time. Wait time as the time a unit spends waiting between two consecutive process steps or workstations. This can be due to equipment downtime, resource unavailability, or other factors. Minimizing wait times is essential for streamlining operations and reducing idle periods. Inspection time. Time spent inspecting and assuring the quality of a unit after processing. This includes both manual and automated quality control processes. The importance of efficient inspection to maintain product or service quality while not causing undue delays. Move time. It is the time taken to transport a unit or product from one point to another within a process or facility. This may involve conveying materials, parts, or products. Optimizing move time is crucial for ensuring a smooth flow of materials and products through a process. Next is cycle time calculation. A simple formula to calculate cycle time, such as cycle time total production time divided by total units produced. Example calculation. Total production time, this is the time taken from the start of the production process to the completion of a specific number of units. It includes processing time, waiting time, and any other time components involved. Total units produced, the number of units that are successfully produced during the total production time. For example, let's total production time 8 hours. Total units produced 400 units. So cycle time 8 hours to be divided by 4 units. And result will be 0.02 hours per unit or 1.2 minutes per unit. It helps organizations measure the time it takes to produce a single unit, which is vital for evaluating and improving process efficiency. Common errors to avoid when calculating cycle time, such as inaccurately measuring production time or miscalculating the number of units produced. Next is how to reduce cycle time. Shorter cycle times lead to increased efficiency, cost savings, and improved customer satisfaction. Strategies for reducing cycle time. Various strategies and best practices that organizations can implement to reduce cycle time. Process streamlining. Streamlining processes to eliminate unnecessary steps, bottlenecks, or redundancies can significantly reduce cycle time. Automation. Incorporating automation technology where applicable can speed up tasks and reduce processing time. Cross-training. Training employees to perform multiple roles can prevent work stoppages due to resource unavailability. Just-in-time JIT manufacturing. Implementing JIT principles can minimize wait times and reduce inventory carrying costs. Quality improvements. Enhancing product or service quality can reduce inspection time and the need for rework. Supply chain optimization. Optimizing the supply chain can lead to quicker access to materials and reduce move times. Rapid prototyping. In product development, using rapid prototyping techniques can speed up the design and testing phases. Next is benefits of cycle time, such as increased productivity and throughput, cost savings through reduced labor, energy, and storage costs. Next is continuous improvement for cycle time reduction. Continuous improvement is an ongoing and systematic approach to making incremental and positive changes in processes, products, or services. It's a fundamental principle for organizations seeking to enhance their efficiency and competitiveness. Key elements of continuous improvement. Data collection and analysis. Stress the importance of collecting data related to cycle time and other process metrics to identify areas for improvement. Kaizen. Mention the Japanese term Kaizen, which represents the philosophy of continuous improvement, focusing on small, daily changes that accumulate over time. Employee involvement. Discuss the role of employees at all levels in contributing to and leading improvement efforts. PDCA cycle. Explain the Plan Do Check Act (PDCA) cycle, a problem-solving and continuous improvement framework. Benefits of continuous improvement. The benefits of implementing a continuous improvement culture, including sustained cycle time reduction and efficiency gains, enhanced quality and customer satisfaction, increased employee engagement and empowerment. Next is tools and techniques. There are various tools and techniques available to help organizations measure and optimize cycle time. These tools are essential for gaining insights into current processes and identifying areas for improvement. Value Stream Mapping. Value Stream Mapping (VSM) as a visual tool used to document, analyze, and improve the flow of materials and information within a process. It helps identify bottlenecks, delays, and non-value-added activities in the process. Process flowcharts. Process flowcharts are visual representations of a process, illustrating the sequence of steps, decision points, and interactions between various components. They are useful for analyzing the flow of work and identifying areas for cycle time reduction. Time and motion studies. Time and motion studies involve observing and recording the time required to complete specific tasks within a process. This can help pinpoint inefficiencies and areas for improvement. Benchmarking. Benchmarking as a technique that involves comparing an organization's cycle time performance to that of other industry leaders or competitors. It can reveal areas where improvements are needed. Simulation and modeling. Simulation and modeling involve creating computer-based models of processes to test various scenarios and identify optimal configurations for reducing cycle time. Lean and Six Sigma tools. Mention that Lean and Six Sigma methodologies provide a wide range of tools and techniques for process improvement, including tools like 5 Whys, Pareto analysis, and make, define, measure, analyze, improve, control, for structured problem solving. Software solutions. Nowadays, there are software tools and solutions designed for process analysis, including cycle time measurement and optimization. These tools often offer automation and data analysis capabilities. These tools and techniques are essential for understanding current processes, identifying areas for improvement, and monitoring progress over time. Thank you for your attention. If you have any questions regarding cycle time calculation and optimization, please feel free to ask anything related